According to data from the Food and Agriculture Organization, the world produces over 25 million tons of cotton every year, enough to make more than 25 billion t-shirts. Across every continent, this single fiber weaves through daily life, from the clothes we wear to the beds we sleep in. Yet few people have ever seen how a soft white bloom turns into the thread that shapes our world. In America, vast fields of cotton stretch across the southern states, feeding a billion-dollar textile industry that never sleeps. Today, Captain Discovery steps inside the modern cotton factory to uncover how nature's fluff becomes the foundation of fashion. Cotton has been woven into human history for over 5,000 years. Ancient civilizations in India and Egypt spun its fibers into cloth long before machines existed. In the 18th century, Britain's Industrial Revolution turned cotton into the engine of modern manufacturing. Then, in 1793, American inventor Eli Whitney created the cotton gin, a machine that could clean cotton 50 times faster than by hand. This invention transformed the U.S. South into the world's cotton capital, fueling both the economy and the birth of large textile mills. By the 20th century, cotton had become a symbol of comfort and everyday life, from denim jeans to white t-shirts hanging in American closets. Today, advanced machinery and automated harvesters have replaced hand-picking, but the journey from field to fabric still begins with a simple seed. So how does that seed become the soft thread we wear every day? Every cotton journey begins in the field. Farmers prepare the soil by plowing and removing weeds, creating a soft bed for the seeds. The rows are carefully spaced so each plant receives enough sunlight and nutrients. Planting happens in spring when warm days and longer sunlight hours encourage fast growth. Within 5 months, the plants mature, and white blossoms open at the ends of the branches. When the pods dry, they burst into fluffy white cotton ready for harvest. Modern machines now do the job that once required entire teams of workers. A single mechanical harvester can pick as much cotton in one day as 250 people once did by hand. Spiked drums pull the lint from the pods while powerful air fans blow it into collection bins. These machines operate continuously across acres of farmland, gathering tons of fiber each day. Once the bins are full, the cotton is compressed into giant modules that hold about 15,000 pounds each. These modules are covered and loaded onto trucks headed for ginning plants. The first transformation from plant to fiber begins there. So how do factories clean and separate the cotton once it leaves the field? At the ginning plant, freshly picked cotton arrives in large, compacted modules. Conveyor belts feed it into powerful cleaners that remove sticks, leaves, and sand. Inside the gin, rotating saw blades and steel ribs separate the soft fiber from the tough seeds. This is the same principle used since Eli Whitney's 1793 invention, now performed by machines processing several tons per hour. Hot air flows through ducts at over 90 degrees Celsius to evaporate moisture and carry away debris. The cleaned fibers move through a series of filters and screens that catch any leftover fragments. Seeds fall through chutes into separate containers and are later pressed into cottonseed oil or used as livestock feed. Each gin line can handle up to 60 bales per hour, keeping pace with massive farm outputs. After separation, the pure lint is pressed into rectangular bales. Each weighs about 226 kilograms and can produce more than 10,000 t-shirts. Labels and barcodes are attached for traceability. Trucks then transport these bales to spinning mills where the fibers will become yarn. But before that happens, the raw fibers still need careful blending and alignment. How do mills turn loose lint into smooth, continuous thread? Inside the spinning mill, machines open the bales and fluff the fibers into light clouds. Blending chambers mix cotton with polyester or rayon to improve strength and stretch. The mixture falls into a carding machine, a massive cylinder covered with fine wire teeth. As it spins, it combs the fibers, straightening them into a long, soft strand called a sliver. Each sliver stretches over 6,000 meters in length. Several slivers are combined and gently drawn to even out their thickness. For premium yarns, a combing stage removes the shortest fibers, leaving only the longest and smoothest. The final drawing frames twist the strand slightly, giving it enough strength to become yarn. Ring spinning machines then pull, twist, and wind the yarn onto metal spools at speeds up to 15,000 revolutions per minute. The finished cones, each weighing about 2 kilograms, are checked for tension and uniformity. They are packed and shipped to textile factories across the country. The fibers have now become strong, flexible threads. Next, those threads will meet thousands of tiny needles that will weave them into fabric. How does that transformation happen? At the textile factory, cones of yarn are loaded into massive circular knitting machines. Each has hundreds of tiny steel needles that loop the yarn together to form a continuous tube of fabric. The motion is hypnotic, the sound steady like rain on metal. In one line, 108 threads interlock under the movement of 1,620 needles, producing hundreds of meters of cotton cloth every hour. Once the fabric is formed, it is inspected for holes, uneven tension, or color variations. The undyed fabric, called graige, feels stiff and pale. It then enters a series of dyeing tanks, where color and softness are added. Because cotton often mixes with polyester or rayon, each fiber must be dyed separately. Polyester absorbs color at about 130 degrees Celsius, while cotton and rayon take dye at 60 degrees Celsius. After coloring, the fabric passes through dryers at 160 degrees Celsius. Mechanical frames hold the edges tight to prevent shrinkage and distortion. The cloth exits soft, bright, and uniform in shade. It is now ready for cutting and sewing. But how do factories turn these endless rolls of fabric into the garments we wear? The finished cotton fabric is rolled into wide sheets and sent to cutting rooms. Technicians load the rolls onto automated tables that stretch the fabric into many layers. A digital pattern system arranges shirt panels, sleeves, and collars like puzzle pieces to minimize waste. Computer-guided blades slice through dozens of layers in seconds, producing hundreds of identical parts. Bundles of cut fabric move to the sewing floor, where thousands of machines hum in rhythm. Each operator performs one precise step: stitching shoulders, attaching collars, or hemming edges. A single shirt can pass through 13 skilled hands before completion. Every seam is checked for strength, alignment, and smoothness. Defective pieces are instantly removed. When complete, the garments are pressed with steam irons, folded, and packed into boxes. From the moment the cotton was planted to this point, less than a week may have passed. Each piece now carries a story of machines, fields, and human precision. And that is how a simple cotton plant becomes the fabric that clothes the world. According to data from Statista, the world produces more than 2 billion t-shirts every year, enough for every person on Earth to own several. Yet behind this simple piece of clothing lies one of the most complex production systems in modern industry. Every shirt begins as loose fibers that travel through hundreds of machines, spinning, knitting, dyeing, and stitching until they become a finished product. In one American factory, more than 3,000 sewing machines work non-stop, turning out shirts in less than 2 minutes each. What seems ordinary on a store shelf is actually a triumph of precision, speed, and design. So, how does a simple t-shirt come to life inside the factory? The t-shirt story began more than a century ago, not as casual fashion, but as workwear. In the early 1900s, the U.S. Navy issued lightweight cotton undershirts to sailors because they were easy to wash and dried quickly at sea. By the 1950s, that same garment had moved from the ship deck to the streets, thanks to Hollywood icons like Marlon Brando and James Dean, who turned the plain white tee into a symbol of rebellion and youth. Factories soon adapted, producing millions every year as demand exploded. By the 1970s, screen printing transformed the t-shirt again, turning it into a wearable billboard for music, sports, and politics. Today, the global t-shirt market exceeds $45 billion, with new materials and digital printers replacing manual work. But how do modern factories turn a bale of cotton or polyester chips into the soft shirts we wear every day? Every t-shirt begins with fiber. Most factories use cotton, polyester, or a blend of both. Cotton is chosen for its softness and breathability, while polyester adds durability and keeps the fabric from shrinking. Giant bales of cotton weighing around 500 pounds arrive at the mill, while polyester comes in the form of small plastic chips made from refined petroleum. Machines open the cotton bales and fluff the fibers, removing dirt and debris. For blended shirts, the polyester fibers are mixed in measured ratios, such as 60% cotton and 40% polyester, to create the ideal balance of comfort and strength. The mixing chambers look like enormous blenders, stirring tons of fiber every hour. The goal is uniformity. Each strand must feel identical in texture and length. Quality sensors check fiber thickness to ensure consistency across every batch. The prepared fiber is then ready for spinning. But how can a loose pile of fluff become a single continuous thread strong enough for fabric? Spinning is where fiber becomes thread. The cleaned and blended fibers pass through carding machines equipped with fine wire brushes that align the strands. The tangled mass transforms into a long, rope-like strand called a sliver. Each sliver can stretch up to 6,500 meters and weighs about 1 kilogram. Several slivers are then combined and drawn through rollers to make their thickness uniform. For premium shirts, the fibers go through an additional combing process that removes short strands, leaving only the longest and smoothest. The drawn sliver enters a spinning frame that twists it thousands of times per minute. This twisting gives the yarn strength and elasticity. Finally, the yarn is wound onto cones that each weigh about 2 kilograms. Every cone is tested for tension and color before packaging. The yarn must be perfectly balanced to survive the next stage, knitting. So how do these thin threads turn into fabric wide enough to become clothing? T-shirt fabric is created using large circular knitting machines. Each machine contains hundreds of steel needles that move in a synchronized rhythm, looping yarns together at high speed. The sound is constant, a mechanical heartbeat that fills the factory. As the machine spins, the yarn interlocks to form a seamless tube of fabric. The most common structure is the jersey knit, known for its soft surface and natural stretch. Other types, like ribbed or peak knits, are used for cuffs and collars. The machine can produce over 30 meters of fabric every minute, feeding the continuous roll onto large bolts. Once knitting is complete, every roll is inspected under bright lights for dropped stitches or tension flaws. Defective sections are trimmed away before dyeing. The fabric, still gray and stiff, is called grage. The next question is, how does this plain gray cloth gain its softness and color? The greige fabric is loaded into huge dyeing machines that can hold over 1,000 pounds of material at once. Each batch is treated in a sequence of chemical baths that clean, bleach, and color the fabric. Hot alkaline solutions remove natural oils and waxes, while hydrogen peroxide creates a bright white base. Then comes the dye bath, where color is absorbed into every fiber. Cotton and polyester react differently, so the dyeing process uses separate cycles. Polyester is dyed at about 130 degrees Celsius, while cotton takes color at around 60 degrees Celsius. The fabric circulates inside the tank for several hours to ensure even tone. After dyeing, it moves through dryers set to 160 degrees Celsius. Stretching frames hold the edges firm to prevent shrinkage. Finally, softeners are applied to give the fabric its smooth touch. Each roll is cooled, pressed, and prepared for cutting. Now that the cloth is ready, how do factories shape it into the familiar form of a t-shirt? In the cutting room, long tables stretch up to 30 meters. Workers spread layers of fabric in stacks, sometimes over 100 sheets thick. A computerized marker system lays out digital patterns for each shirt size: front, back, sleeves, and collar strips. Automatic cutting blades follow the lines precisely, slicing through every layer in seconds. The cut pieces are bundled and sent to the sewing floor. Each operator specializes in one job: joining shoulders, attaching sleeves, or sewing hems. The production line moves quickly, with every shirt passing through about 13 pairs of hands. Industrial sewing machines can complete more than 5,000 stitches per minute. Quality supervisors check seams and labels before the shirts move to the finishing section. A shirt that once began as raw fiber is now fully assembled but still unpressed. So what happens before it reaches the store shelf? The final stage gives each shirt its crisp, finished look. Steam presses flatten wrinkles and set the fabric's shape. Machines equipped with heated molds press dozens of shirts at a time, keeping collars flat and hems even. The pressed shirts move along conveyor belts to folding stations. Automatic folders tuck in the sides, align the sleeves, and insert a cardboard sheet to maintain shape. Each shirt is labeled with its brand, size, and care instructions, then sealed in a transparent poly bag. Random samples are pulled for inspection under strong light to check for color consistency, thread quality, and stitching alignment. The completed boxes are stacked onto pallets and shipped to warehouses. From there, they travel to stores across the country, ready for customers to pick up without ever imagining the machines, heat, and precision that brought them to life. So the next time you pull on a t-shirt, you'll know the quiet complexity hidden in its simple fabric. Every year, factories around the world produce more than 8 billion bath towels, enough to wrap around the earth over 30 times. According to the Textile Exchange, global cotton production for towels alone exceeds 2 million tons annually. But behind every soft, absorbent towel lies a story of precision engineering and textile science. It takes hundreds of steps to turn raw, fluffy cotton into the familiar fabric we use every morning. Each thread must be spun, woven, dyed, and finished with exact control over tension, temperature, and moisture. Today, Captain Discovery explores the modern towel factory to uncover how ordinary cotton becomes one of the most comforting products in our homes. The bath towel traces its roots back to the 18th century Turkey, where artisans in Bursa began weaving soft cotton fabrics known as terry cloth. The name terry comes from the French word tirer, meaning to pull, describing the tiny loops that make the fabric absorbent. By the 1850s, British manufacturers refined the process, using mechanized looms to create the first industrial towels. When cotton became widely available after the Industrial Revolution, the towel evolved from a luxury item into a daily essential. In the United States, demand soared during the 20th century as hotels and households embraced the idea of personal hygiene. By the 1960s, American mills produced millions of towels each year, and modern terry weaving machines could create loops with perfect height and density. Today, automation, quality control, and design precision continue that long tradition. So how does raw cotton become a soft, absorbent towel ready for your bathroom? Every towel begins with cotton. Factories receive it in massive compressed bales, each weighing around 500 pounds. Inside, machines open and clean the fibers, removing dust, seeds, and plant debris. The clean cotton is then carded, a process where rotating drums covered in fine wires separate and align the fibers. What comes out is a long, fluffy strand called a sliver. For premium towels, the sliver is combed again to remove shorter fibers, leaving only the strongest and smoothest ones. Slivers are drawn and twisted in spinning frames running thousands of revolutions per minute. This twisting gives the yarn strength while keeping it soft to the touch. Two types of yarn are made: the firm, ground warp that forms the towel's base, and the loose pile yarn that creates its soft loops. Both are wound onto cones and checked for even tension. But how do these simple threads transform into the textured fabric that absorbs water so well? In the weaving hall, huge looms turn yarn into cloth. Thousands of warp threads are stretched across the machine, creating the towel's backbone. Each loom can handle over 2,000 threads at once, interlacing them with the weft yarns that run across the fabric. What makes a towel unique is its looped surface, known as terry. To form these loops, looms are programmed to give the pile yarn extra slack at precise intervals. When the shuttle locks the weft in place, the loose sections rise to create soft loops on both sides of the fabric. By adjusting the tension, manufacturers can make long, fluffy piles for luxury towels or shorter ones for quick-drying models. One loom can weave hundreds of yards of fabric in a single shift, all perfectly aligned. The newly woven cloth, called grage goods, is still stiff and dull. It must now be cleaned and softened before it can touch human skin. The grayish fabric enters a series of washing and chemical treatment lines. First comes desizing, where hot water and enzymes remove starch from the warp yarns. Then scouring uses alkaline baths at 95 degrees Celsius to eliminate natural oils and waxes that prevent absorbency. Without this step, water would simply roll off the towel instead of soaking in. Next, bleaching tanks filled with hydrogen peroxide whiten the cotton, creating a bright, uniform base for color. Once clean, the fabric moves into giant dyeing drums, where it circulates through heated dye baths. Each load can hold up to 1,000 pounds of towel fabric at once. The dye penetrates deep into the fibers, fixing the color under pressure. After rinsing and neutralizing, the fabric is dried and steamed. The result is a sheet of pure color, soft, vibrant, and ready for finishing. But how do factories make it feel as fluffy as the towels in a luxury hotel? In this stage, the towel gets its final texture. The dyed fabric passes through a tenter frame dryer, which holds the cloth at a precise width while drying it evenly at 160 degrees Celsius. Silicone-based softeners are sprayed onto the fabric surface to lubricate the fibers, making them move freely against each other. This process gives the towel its plush, flexible feel. Next, the fabric moves through a raising machine. Rotating cylinders covered in fine metal wires brush the surface gently, teasing out the loops and increasing softness. For velour towels, the loops on one side are trimmed to create a smooth, glossy surface. Temperature, humidity, and tension are constantly monitored by sensors. Even a small variation can affect absorbency. Once the towel meets the desired weight and touch, it is rolled and sent to the cutting section. So how do these massive rolls turn into perfectly shaped bath towels? The final transformation takes place in the sewing room. Huge rolls of terry fabric are unrolled and fed into automatic cutters that slice them into standard sizes, 27 by 52 inches for bath towels. The raw edges are folded twice and stitched on industrial sewing machines that make thousands of stitches per minute. Labels, borders, or decorative hems are added during this stage. Some factories even use computerized embroidery machines to weave brand logos directly onto the fabric. Every piece is inspected under bright lights for color consistency, stitching quality, and loop density. Once approved, the towels are steam-pressed, automatically folded, and wrapped in plastic film. Stacks of finished towels are boxed, labeled, and shipped to hotels, stores, and homes worldwide. And that's how simple cotton becomes one of the most familiar comforts in daily life. A towel that's ready every morning to absorb, dry, and start the day again. From the cotton fields of the South to the humming textile mills of Los Angeles, every thread tells a story of precision, patience, and progress. The same fiber that once clothed ancient civilizations now powers billion-dollar industries that make our shirts, towels, and countless other essentials. Each product may look simple, but behind it lies a world of engineering where machines spin thousands of threads per minute, dyes flow through giant tanks, and workers monitor every color, texture, and stitch with absolute focus. What connects them all is the quiet beauty of production, how raw materials turn into something familiar and human. A cotton boll becomes a shirt, a spool of yarn becomes a towel. It is the rhythm of modern craftsmanship, hidden behind everyday life. If you've ever wondered how the things around you are made, this is just the beginning. Subscribe to Captain Discovery and join us inside the next factory, where the ordinary becomes extraordinary, one process at a time.